we've been learning about functions, exponential functions. We're calling it a function simply because we've now named it, right? But we are learning about when we have what we call a base and we are now raising it to a power. So we've gone the opposite of not knowing what we're plugging in, but knowing what we're raising it to, versus knowing what our base is, just not knowing how many times we're actually multiplying it. Who can tell me where we use exponential, where I talked about where we use exponential functions the most? What is our base? What are we usually talking about when we're dealing with a base and then an exponent? Okay. Typically, this is time.
Oh, yeah.
Okay. So our exponent is typically time. So when we're talking about growth, these are our growth and decay formulas. This is what we're looking at. So what it's saying is that we have some sort of multiple, right? If it was a 2, we would know that it would do what to the equation, to the answer each time?
Double it.
It would double it each time. If it's 3, it does what?
Triple
it. The answer triples each time. If it's 4, it would quadruple. If this base is 1/2,
it halves every time.
it would go down each time. It would break it in half each time. So our base tells us what is happening to our answer. Our exponent tells me how many times we need to do that. So that's what so we have a chart, either a decay function or a growth function. Our base gives us exactly what our function is. Our exponent tells us where on that line we're going to stop and therefore find an answer. Okay, so it's giving us that actual point of it. Make sense? So typically we are dealing with time most of the time. Most of the time we're dealing with time. Months, years, because if we're dealing with money, depreciation, appreciation, interest, then we're getting a money amount. We've got time. In science, they use it like in petri dishes. I mean, if you look at how the embryos grow, and when you're born, so you have 1 egg, it splits in 2. Now you have 2, they split in 2. Now you have 4 cells. This is cell growth, cell division, and rates. So our bodies are made up of this, God's design of that, okay? So logarithms, as we have learned in math, everything has an opposite, right? Opposite of addition,
Subtraction.
opposite of division,
Multiplication.
opposite of exponents,
Square root.
square roots. Thank you. Okay, so everything has an opposite. So now we have learned something new. We have to learn the opposite of that. All right? The opposite of our exponential functions are called logarithms. Okay, logarithms. We simply take the first part and have log. So if you see something that has log and then random things on it, we are looking at the opposite. Okay, so right now what I'm going to leave up here, we're going to leave these two together and I'm going to explain the different parts of it. Okay, so on the paper that I handed you out first, we're going to walk through this one, a little bit of logarithms. Now when it says logarithms are used to find the exponents when given the base. Okay, so here we are trying to find the answer, right? So we might say, we've got this function, I know my base is 3, and I'm multiplying it over 5 years. So I would have 3 to the 5th, which would then give me, I think it's 243. So I'm finding an answer. What happens when you already have the answer? I have 27 equals 3 to the x, and I want to know what x is. In this case, this is a simple one. What would x be?
3.
X would be 3. Okay, it's nice when it's simple. When it's not simple, you're like, ugh. basically I'm having to rearrange my equation for x. So typically if we had a multiplication, we would divide. We would do the opposite sign, right? If I had 27 equals 3 plus x to solve for x, I would subtract 3 from each side, right? So we're always going to do the opposite. In this case, because your x is the exponent, the opposite is to use a logarithm. So this is the mathematical way. This is the subtraction, or the division, or the square root of an exponent, okay? So there's a way that you write it, and they on here say log, and they've got base, then equivalent value, and exponent. I like, since we talk about this, they call this the equivalent value. I call it the answer or the solution. You know, we typically know that. So in this, when we have a log, we have our base. We have our answer. I like it because it's A, and A means answer to me. So I've got base, I've got my answer, and then I've got x, right? My equivalent value is my exponent, so there's my x, okay? So if I were to look here, what did we have initially? We had our answer is equal to our base raised to some exponent, right? Could we rewrite our exponential function this way? Our answer is equal to our base raised to our exponent. Okay, do we have all the same rules, all the same variables now?
Yeah.
Yes. Okay. What if we do that? Our base raised to an exponent gives us our answer. This is the easiest way for me to visually keep the numbers in the right order. We start with our base and we circle around. Okay? If I were to take log of 525 equals x, this looks real confusing. If I circle it around and I rewrite it, this means 5 to the x equals 25. See how I've written that? We have our base, this is our b, raised to some power gives me the answer of 25. So in this case, x would be 2. X would be 2. So the way that we would write this would be log of 525 equals 2. Okay? Base raised to a power gives you your answer. So think of it in this circle on that way. Okay? We can also, it's just, so let's look at this one. If I have 125 equals 5 to the third, which number is my base?
5.
5. So this is my b. That's my base, right?
You just said the.
What?
Never mind.
That's not log, right?
This is 25, not 125. If my exponent is 3, right? My answer is 125, right? So to rewrite this in logarithm, we would have log, our base goes first, so what number do we put first?
5.
5, and it actually goes a little bit down, so you have a little bit down, a little bit up. It's like a split-story house. If you've ever had, my grandmother had a split-story house. It's like 4 steps down to go there, and 4 steps up to go to that one. Okay, so our base goes down first, our answer goes at the top. What would our answer be?
125.
125, and that would equal 3. Okay, so if we were to rewrite it as our circle, 5 raised to the third, and because this one's a little bit lower, gives us 125, gives us our answer.
So how do you solve one again?
We're working there.
Oh, sorry.
Okay. All right, so in this case, and they have a little bit, they have a little section here called natural logs. Your calculators, we're gonna talk through that solving it, because your calculators have a button that says LN. It also has a button that says log 10. So you will see LN, and then you'll see a button that says log 10. When you have, LN means a natural log. Okay. That is also written log, the E. They call it E. I haven't come up with a good reason of why they call it E yet. Okay. If you see log with the base, remember whatever's down low, the base is E, that is a natural log. And it tells you on here where E is equal to about 2.71828. It's kind of like a pi number. Okay, but whenever you see log E, then on your calculator you can use your natural log button of it. All you need to know is that these two things are the same. Okay, that's all you need to know for that. Your calculator also has a button called log 10. Well, that's a problem when you don't have the base of a 10, right? Let's think about what that really means. That means 10 raised to some power. Why do you think it would have this? What else does it have? When we're looking at, does this look like scientific notation?
Yeah.
Right? Some number times 10 raised to some power. Right? So this is the rewritten form of scientific notation. Your calculator can give you scientific notation, correct? Because it has 10 raised to a power for it. So that's why we have log 10. It's the opposite of the scientific notation base, okay? So that's why they choose those on your calculator. Okay. So the little section here that says change of base, and this is simply, you have to memorize this. You just have to know it. It's really not super hard. Because your calculators use log 10, you want to be able to solve problems that are not log 10. Correct? So instead of saying, hey, I have a base that's 10 raised to some power, well, in this case, I have a 5 that's raised to some power. I want to be able to solve that. How do I use my calculator to solve that? The way that you do that is you take this section that you have here, okay, and you're going to use a division for that. Okay, so it says to change a log's base, we use the change of base formula. Okay, so this, when in our original equation, we have, oh, and they changed it here. I'm actually going to leave it in this order, and it's going to look backwards on your paper. Okay, they wrote log of A raised to B. Okay, I'm going to change that, log of B raised to A, so that we can say, keep that consistent. It's the base raised to the answer, the base to the answer for it. So in that case, basically all you're doing here is you're putting a division sign right between these two numbers. All right, so do you see that? It says log 10 raised to the B, so whatever's on top, or whatever's on top in this case, it's our A. So if we have, let's put it in real numbers, 3 to the 5th. Okay, to change this into base 10, this would be log base 10 to the 5th divided by log 10 to the 3rd. We're going to put a division sign between the top and the bottom, and we're going to split them up. Okay? We lost yet? Lots of info. Right? So, it's not a super confusing thing. You just have to remember when my base is not 10 and I want it to be 10, I have to divide these numbers up. And what that will give me is a new, it will still give me a proper answer. I can use my calculator now to solve this. These give the same answer. All right? Did anyone bring their calculators?
I found.
Do you have your phone that you can turn sideways?
Yeah.
Okay, let's work that out. Let's work out this one that we were just doing. Okay? We are going to try to figure out this one. We know what it is, but we're going to work it out with our calculator to see what it is. All right, so log 5 to 125 equals x. We know that this is telling us we want to find 5 to the x is equal to 125. We happen to know the answer in our head because this is an easy one, okay? But we're going to work it out. So to reuse it with your calculator, what would we write on top? Log 10, what number do we choose here?
125.
125. Remember, we're simply dividing this. On the bottom, we've got log 10 to the 5. Okay. What I want you to do, Nathan, will you do this one? On your calculator, if you turn your phone sideways, it gives you all those little extra ones.
Yeah.
You type the answer, and then you hit the button. Okay? So type 125 in, and then hit your log 10 button. Okay? Give me an answer to 5 digits, please.
2.0969.
One more.
1.
Okay? Okay, Nazarene. To do log 10 to 5, you're going to type a 5, and then you're going to hit the log 10 button.
0.69897.
Okay. Tadrian, divide these two numbers.
Today, sir.
3.
What?
3.0 da 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 0
29 point something.
should be 3. 2.09691
Oh, I got exactly
divided
3.
by 0.69897. 3.
Yeah, I got exactly 3.
3. Okay? So, the answer that we got is our x value. 5 to the third equals 125. Is that correct?
Oh, that's how we get the x.
Now we have the answer.
Okay.
So what we have done is our calculators do not have when there's a base other than 10. Right? So what I'm showing you is a way to solve it. We're going to divide this problem in half so that we can use our calculators to get the answer. We are rewriting our equation. That's all we're doing is rewriting the equation. All right, we're going to do another one. If I had 4 to the x equals 16,384, how would I write that as a log?
Log 4 16,384 equals x.
Perfect. Right? Our base raised to our answer gives us our exponent. But it's not really raised, it's just the order that it's in. Okay, now, Can we use a calculator to solve this?
Yeah.
As is?
No.
No. We have to do what?
Regular division.
We're gonna divide it into 2. So we have log 10, 16,384. Log 10 to the 4, we are rewriting. That's going to give us our x value. Okay? Micah, do this first one.
Done.
What is it?
4.21441.
Okay? Nathan, next one.
0.60205.
60205. Okay? Nazarene, divide.
Seven.
7.
How'd you do that so good?
Excellent. So what do we know? 4 to the 7th is 16,384. All right? Do we have an understanding? Is it a little bit easier than what you thought it was in the first place? Maybe? The hardest part is knowing what the numbers mean. Okay? So it's important that we know the base. Remember, the base is always on the bottom. So even when it's rewritten differently, like even if you have like log a to the b, you know, your base is on the bottom, your answer's on the top, what you get on the end, your solution is your exponent. Okay? Remember our order that way. Okay, so on the back,
It's a
I always forget
there was
there's
actually a
back.
second. What?
I always forget there's a back.
There's a back. Okay, on the back, we're gonna do we're gonna go through characteristics of logarithms, and then we're gonna have a couple of properties. I'm gonna look at my time. Because logarithms are really what? Exponents, right? Isn't that what we're working with? We can use our rules of exponents. Remember the paper way back at the beginning, there was like stapled 3-page note thing on our rules of exponents. So we are not learning anything new. We're going back to the same things that we had before, saying this is true for all exponents. So if it's true for all exponents, it has to be true here. Okay? So we learned last week with exponents that any number raised to the 0 is equal to what?
1.
1. Always. This is a property of exponents. Any number raised to 0 is 1. Right? So if I rewrite this, how would I rewrite this as a log? My base is x. My answer is, my exponent is 0. So any log of a base to the 1 will always be 0. We have simply taken the rule that we know as an exponent and rewritten it in its opposite form as a logarithm. Got it? Okay. So let's look at our rule of any number raised to a 1. What is any number raised to the power of 1?
Itself.
It's itself, right? So how would we rewrite that as a logarithm?
Log x over x.
X to the x is equal to
1.
1. So when you have a logarithm and the numbers are the same, the answer is 1. We're taking our rule of our exponents, we're rewriting it as a log. Following? Yes? Okay. So that's those first two ones. So let's look at this. If I have a number, this one, raised to a different number, and I don't like, so I've got x raised to the 3rd, okay? Let's do this one. How would I rewrite that as a log? Equals some answer. We'll do this. Some answer b. How would I rewrite this as a log?
Log x b, or like
Uh-huh,
Yeah, equals 3.
equals 3, okay? So if I replace that, let's write with an A, then I would replace this one with an A, right? So we're just replacing numbers. Let's look at what they wrote. They wrote log A to the AR is equal to R, okay? This is a lot of numbers. Let's rewrite it in our regular exponent. What does it say? Our base raised to our answer, right? Or to our exponent is equal to our answer. Is that true? Yes. A to the R equals A to the R. Perfect. Because this is our answer. This is our base raised to the power. Okay. So this is for anything that's other than 0 or 1. So any base raised to any power is going to give you that base raised to that power. Right? So it looks super confusing, but all we've really done is just rewrite it. Right? We've taken our exponent rules, we've rewritten it. So if I have log 10 to the 5, what do I know right away?
That far thing's 5.
It's 5.
Yeah.
So when we have our base matches the base of this one, we simply have our exponent, right? Log 2 to the 4th
Equals 4.
would equal 4. Excellent. Log 3 to the x
X. It equals X over there.
equals x. Okay? Our base raised to a power is equal to the base raised to the power. So all we're doing, these are canceling, and our answer is our exponent. Okay? So that's that second rule that it has there. Okay. Now, I'm going to go slow on this one. Okay. Remember, logs are the backwards. Remember, we're going backwards from the exponents. When we have an exponent and they're multiplied, x to the 3rd times x squared, what was our rule?
Plus.
You add the exponents. Okay. So in the big scheme of things, and we'll walk through it a little bit, what we are doing is because we're doing the opposite, okay? 3 to the x. This, I'm going to write it this way, just so that you can kind of see it's not technically that. When we have the same exponent power here, when we're switching it, when we have logs that are now added, we're multiplying the exponents. Do you see how, like, when we switched it, now the addition is on the bottom, the multiplication is on the top? Okay, so let's look at what they show. They say log of a to the m plus log of a to the n. Okay? So again, we're back to our exponent rules. We can't do anything unless our bases are exactly the same, right? Isn't that our rule? Our bases have to be the same. So we have similar bases, equivalent bases. Now I have an addition on the bottom. So what am I going to have on the top?
Amen.
I'm going to have multiplication on the top. So when my base is the same and I'm adding them together, I now multiply my answers, right? So let's look, I like the example that they put through there. So let's do log 3 to the 9th plus log 3 to the 27th. So let's rewrite it as an exponent first, before solving this. Let's rewrite it as an exponent. How would we rewrite this one? what could I rewrite this as? 3 to the
X.
x equals 9, right?
Mm-hmm.
How would I write this one?
3 to the x equals
We'll
2.
use y. I'll use a different one. Or let's use, we'll pick this one for m and that one to the n, okay? Equals 27, right? So in this case, I have 3 to the m. What if I have, and I add 3, because so we're still adding them, right? 3 to the n. What do I have up here? mn. Hold on. Let me not do it that way. Sorry. Sometimes I told you I'm going to backtrack. Okay. What do we know? Let's write it as the real answer. 3 to the m, 3 to the what equals 9?
3 second power. 2.
3 squared. Okay. What do we know? 3 to the what equals?
Cubed.
3 cubed. Okay. Okay. If I have 3 squared times 3 cubed, what do we do?
Add.
We're going to add that. That's going to be 3
Fifth.
to the 5th.
To the fifth.
Okay. What is 3 to the 5th?
That's 283, right?
243.
243.
You were close.
243. Okay. What is 9 times 27? Since we've chosen to multiply these. It's number 1 multiplied times number 2. So we have number 1
243.
multiplied times number 2 equals 243. Oops. Okay. So when we take our answers, when our base is the same, if we multiply them, we add our exponent. We ended up with the same answer both directions. Okay? So what they are telling us is here we have the answer. If we multiply our answers, remember, because it said when we add them together, we would do, if this is m and this is n, we would do 9 times 27. That multiplying the answers gives us the same as multiplying our bases with their answers. Right? And did that give us the same answer?
Yeah.
We got 243 both directions.
Yeah.
Okay. So what we can do is sometimes you can then split that up. Sure. Okay. So if I have log 5 and let's do 15. Okay. We could rewrite this as log 5, 3 plus log 5, 5. Correct?
Oh, yeah.
Could I divide that 15 into this? So if you might see this, log 5, 3 plus what? You would know it would need to be the same base, log 5, and then 3 times what gives us 15?
5.
That would be your 5. Okay, so we can always divide a number up. That can be helpful if you don't know how to get to that number from this one, but you do know parts of it. Mostly you're just going to need to be able to visually pick that out. Okay, so in the same way that when we multiplied bases like this, we added the exponents. What happened when we divided bases?
You subtract.
You subtract the exponents. Same thing, right? So same thing with logs. That's the next one. When you subtract your logs, you are dividing your answers, okay? Does that make sense? So we're using the same rule. So on this one, they say, let's say m equals a to the 5. And n equals a to the 3. Okay, so we're going to rewrite log a to the m equals 5. Okay, because remember, m is our answer. So if m is our answer, we are rewriting it, our base here, raised to our exponent, we're circling around, gives us our answer. Base, exponent, answer. Base, exponent, answer. Right? And they tell us that n equals a to the 3, so same thing, base, exponent, so that's got to be on this side, answer is up at the top. Okay? So this says a raised to 5 equals m. Okay, so on this, it says the first part of the equation says a to some power equals m divided by n. So that's way up at the top. So we're trying to figure out what it is. We don't know what the answer is. Okay, so let's think about this. If we actually plug these in, because they give us a, let's look at the roller, equals x. So how would we rewrite that one? Here's our base, raised to the x. The answer is m divided by n, right? This would be our exponent rule if we have this. Log a to the mn equals x. So when we rewrite it as an exponent, a raised to the x equals m over n. So this is what we're looking for. Okay? They give us these rules over here because we're actually, sometimes it's easier to actually work with numbers. So we can figure that out. What do we know that m is? We know that m is a to the 5, right? What do we know n is?
A to the 3.
A to the 3. Well, now I simply have an exponent
Subtract.
rule, right? I have the same base, I have exponents. All we do is subtract 5 minus 3, okay? Which equals 2, okay? But 5 minus 3, this is my answer minus my answer, right? Because that would be, because since this is the exponent, it's the answer of my logarithms. So it's the answer of one logarithm minus the exponent, which is the answer of another logarithm. So when we look at our logarithms, a logarithm means the answer of the exponent. So that's why that's valid. So now I have my answer of one of my logarithms divided by the answer of the other logarithm. You got that? Okay. It's easier to go ahead and plug in numbers and put it back in your exponent rules. Remember, because all we're doing is the opposite of it. So we can see, oh, in an exponent rule, all it was a division sign. So that is all of that. There's another sheet. I'm going to go over these notes. Okay, the properties of logarithm notes that I handed out to you. Okay, so let's look at the first one. The properties of logarithm. Number 1, 0 is always going to be a base with a 1, right? Because the answer in that first one, what is the answer telling us? The answer is 1. So a raised to what power gives us 1? A raised to what always gives us 1? 0. It always has to be 0. Okay. Number 2, same one we went over. Any base raised to the power of 1 gives us itself.
Itself, yeah.
Itself, okay? Now, let's look at this one. The second one, log a to the x equals log a to the y. So it's telling me that the answer, remember that whole thing, log a to the x, this whole thing means some exponent. Okay? It is giving the answer of an exponent. That's what it's meaning. So an exponent is equal
To another exponent.
to another exponent, right? To an exponent. Okay? If x and y are your answers, so if one answer is equal to another answer, then the exponents have to be the same. You're not gonna get, you can't take a base raised to one exponent and a base raised to another exponent and get the same answer. Correct? I can't take 5 to the 2 and make it be 5 to the 3. They're never gonna be the same. So in this case, what it's saying is that when your answers are equal, then, when your exponents are equal, then your answers have to be equal. Okay, so x has to equal y. They have to be the same number. I'm getting a questioning look. Do I need to review that one?
Oh, it's A. A is always A equals A, right?
Yes, so this is your base. This is saying a raised to some exponent gives me x. This one's saying a raised to some other exponent gives me y. Well, if my a's are raised to the exact same exponent, then x has to equal y. Right?
I was confused.
Is that okay? The product rule that is just what we just went over. Oh, no, that's a different one. Okay. So again, if you have the exponent of one term, I think that's probably the easiest way to think about it when you see the whole term of log a to the x. To think of this whole thing is an exponent. Okay, the whole thing is just an exponent. Okay, so the exponent of one thing plus the exponent of another one, right? So this gives me, this is the answer of one, a raised to some exponent gives me x, a raised to another exponent gives, let me do this one, a raised to the b would give me x, a raised to the c would give me y. Okay, so I have these two. If I add these two together, okay, my answer is multiplied. Okay, so remember when we're adding, and that's that opposite of this one. X plus y, when we have our bases the same and they're multiplying, we add them. So now, since we're doing the opposite of it, we know our bases are the same, but we're going to multiply our exponents, and we're going to say basically what we're doing is we are adding our exponents, so we need to multiply our answers. Okay? So anytime you have the bases the same and you have two different answers, it's the same as that same base when you multiply your answers. Quotient rule we already went over. If they're subtracted, we're looking at division. And the power rule, in this case, they wrote it a little bit differently. So same rules as that other one that we were looking at. If I have log a x to the y, how do we rewrite that? This is our answer, right? So a to something, let's make it r. A to the r would equal x to the y. Okay, if we rewrote that, correct? A to the r gives us the answer of x to the y. We can rewrite each one of those. And what ends up happening, without the specifics, is that what we have raised to the power can be put on the front. And we're just multiplying it. We're multiplying it out. Okay? So if I have the log, let's do an example. Log 5, 3 squared. All I'm wanting you guys to be able to do at this point is just to re-decipher what the numbers are, okay? We would take this exponent of 2 and move it to the front. If they said, is this equivalent to 2 log 5 to the 3? You would say, yes, it is. Okay? Let's verbally talk through number 1. Okay, Number 1, log 3 to the 4 plus log 3 to the 7. Are your bases the same?
Yeah.
What is the base?
3.
3. Okay, so it is telling us that some exponent gives us the answer of 4, and another exponent gives us the answer of 7. Okay, so our bases are the same. They're added together. So what do we do to the 4 and the 7?
Multiply.
We multiply them. So what would you have?
Log 3 to the 27.
28.
28. 4
What in
times
the
7?
world? I
28. Okay.
always use
So
27.
it would be log 3, 28. Okay, we're not looking for an actual answer. We're just rewriting, we're simplifying them. All right? Number 2, are your bases the same?
Yeah.
Yes, the base is 2. All right, so 2 to some exponent gives us 12. And we're subtracting
So we divide.
2 to another exponent gives us 3, right? So we're subtracting our exponents. So what are we doing to our answers?
Divide.
Dividing. So that would be equal to log 2 to the 4.
Could you put x equals 4?
What?
Could you put x equals 4?
Yes, you can put x equals 4. Okay,
Are we gonna go into like log and sin and code and stuff?
sine and cosine.
What?
We do have to hit a little bit of trig. That's after spring break. Right?
Are we gonna have a lot of homework spring break?
Stop it.
We have
you won't
we
have
games.
any
Okay, good.
Oh,
we
we
have
don't have
games.
any.
on spring break.
That's great.
Not allowed to give homework on spring break.
Oh, are you gonna like overpack children to do it?
The week
Okay.
before.
Okay, so we're gonna solve for x on that practice. Let's do that first one. Okay, log 6 to the 12 plus log 6 to the 4. Okay, so what are they saying? They're saying our bases are the same, so what do we do to the exponents? What is our new problem? Log 6 to the what?
Multiply and 48.
48. Okay.
What?
Hold on. I don't know why they have that as the answer. Okay, I'm fine with just leaving that.
My G's look
Yes,
like
log 6 to the 48.
Your G's look like 8?
Okay. Now, sorry, mine was wrong. My answer key was wrong. Okay, now, on this one, log 3 to the 8 minus log, here's where we need to know where we're going, log 5 to the 4. Okay, so what does x have to be? I have a
Answer.
3.
answer.
That's supposed to be 5. Sorry, those are all supposed to have the same number at the bottom. That's supposed to be log 5 for all of it. There's a typo on that one. Okay? So now that we have a subtraction, when we're how do we figure out how to subtract exponents? When could we subtract exponents?
Division.
Division.
Okay? When the answers are divided, correct? So we have an answer, one answer divided by another answer. So I have to take my first answer and divide it by my second answer. Remember? We're subtracting the exponents. This whole thing means an exponent. One exponent minus another exponent. To get that, I have to take an answer divided by an answer. So my answer, my first answer divided by my other answer gives me a new answer. What is x? 8 divided by x equals 4.
So x equals 2.
X equals 2. Okay. Again, remember this whole thing, log with your two numbers just means an exponent. Another way to write it is an exponent. Okay. let's look at number 3.
There's no answer.
So let's check our bases. Okay, are our bases the same?
Yes.
Okay. So the first one that we do, and her thing is wrong here. Sorry, I printed this off and like the answers key is wrong. Okay, so our bases are the same here. So we go from left, it's addition and subtraction, so we move from left to right. So the first one that we're gonna do is a subtraction, correct? So log 5 of 24 minus log 5 of 8, what do? We have an exponent minus an exponent, which means we need
To divide.
our answer, which was 24, divided by 8, which gives us 3.
Times.
Okay, so now we can rewrite that. Log 5, 3 plus log 5, 4.
Times.
My bases are the same,
Times the top.
so I need to multiply my answer. I have an exponent plus an exponent, which means I needed to have my answer times my answer, right? To be able to add those exponents. So 3 times 4 is
12.
12. So we have log 5 to the 12, all that simplified. Log 5, 12. All right? Then you guys need to do number 4 on your own.
Right now? Or at home?
That's your homework. Or you can do it now, or study home. Okay?